Let me show you something. So are you ready to watch something together?
Yes.
Very good. So give me a moment to show you something. So let me stop sharing and just give me a moment. Wait a moment to share something else. Okay. Well, if I can find it. Okay, so let me show you. I think this one, if I'm okay. Well, let me share it.
Bubbles, can you bring me my bag? Where is my bag? Why did you not bring my bag, Bubbles?
I couldn't hear you, Spiky.
But I called you so many times.
Oh, maybe because your sound did not travel to Bubbles.
What? Does sound travel?
Yes, sound travels. But how can sound travel? Sound is a form of energy that spreads from its source in all directions. We hear sound when vibrating particles hit our eardrum. Sound moves when the particles hit each other and pass on the vibrations. That's why sound needs a medium for its propagation. The medium may be a gas, such as air, a liquid, such as water, or a solid, such as metal. Do you recall the last time you saw lightning? You saw the flash of lightning first and heard thunder only a few seconds later.
But why did you see lightning first?
Sound travels more slowly than light in air, so sound takes longer to reach us. The speed of light is almost 1,000,000 times faster. Air is made up of gases. The particles in gases are farther apart than in liquids or solids. It takes longer for one gas particle to hit another gas particle and move the sound energy along. Sound can travel through other mediums than air. In fact, in water, sound travels faster and can travel further. Particles in water are closer together. That's why sound travels more quickly in water than in air. Sound waves travel even better through solid things like wood or metal. The particles in a solid are tightly packed, and sound waves travel fastest in this medium. Let's find out how sound travels in solids. Tap your desk with your hand and listen to the sound it makes. Now put your ear on your desk and tap the desk again. Did you notice a change in sound? Which one was louder?
The one that I heard by putting my ear on the desk.
The sound is louder because the sound vibrations travel faster through solids than in air. When you heard the tap the first time, sound waves traveled through air. But when you put your ear on the desk and heard the tap, the sound waves travel through the desk, which is a solid. In outer space, you can't hear anything because there is no air or any other matter. We call this a vacuum. So there is no medium that sound can use to travel. When you see a spaceship explode in space, you don't hear a thing. How fast does sound travel? In air, sound travels with a speed of approximately 350 meters per second. But sound travels faster in liquids, like water, and fastest in solids, like wood. Time for an exercise. We put a cell phone in a jar and hang it mid-air by a thread. We pump the jar vacuum and seal it. Make a missed call for the cell phone inside. Do you hear the ringtone of the cell phone? No, we cannot hear the ringtone of the cell phone. We removed all the air from the jar and created a vacuum. We confirmed that sound cannot travel through a vacuum. Let's summarize. Sound energy needs a medium for its propagation. Sound travels fastest in solids. Sound travels slowest in gases. Sound cannot travel in a vacuum since there are no particles to propagate sound.
Wow. Okay, Hannah, did you get it?
A little bit.
Okay, so let's talk again. Let's talk about, you may got a bit confused, but it's really easy. Look, Hannah, let's play a game. Okay, so there are, okay, let me show you. Let's see, for example, there are the particles of gas, you know? And as you can see, the particles in gases are furthest apart. You know, this one and this one, they're not near, they're not close to each other, okay? And this one, let me show you with another color. This one is liquid. Of course, they can move easily, but of course, they're apart. And in gas, now let me show you another color. And in gas, they're really close to each other, as you can see. Because of this, in solid, we say that they can't move. So, the particles in solid. So we have three phases of matters. Now you can see, okay, I want to make a sound. Here I am making a sound, okay. For example, the name of this particle is Alice, okay. I say, yeah, for example, this one is Alice. I say, Alice, go to Harry. This one is Harry. This one is Harry, and this one is Alice. Alice, go to Harry and say hello. Okay, now, yes, of course. Now, Alice wants to go to Harry. It takes time because Harry is here, so she needs to go. So it takes time, okay? So it should be slow. So say, Alice say, yeah, Harry Potter, okay? But here, now, now let's check liquid. So this is about gas. Now let's check liquid. In liquid, there are part but not two. Actually, part, we say that they are not very close, something they're not stuck, but of course we can consider it as close particles, but not really close like solid. I say Alice. Hello, Alice. Go to Harry. Harry is this one. Harry is this one. Go to Harry and say hello. Okay, now Alice tells Sarah and Sarah tells Harry. So it's faster. You say, okay, Sarah, say hello to Harry because they are close, they're near to each other. And this one, this is solid. They are really, really close. So they can't move. I say, Sarah, this one is Sarah. Sarah, say hello to Harry. Harry's here next to Sarah. So it's really fast. Sarah says, hello, Harry. So it can be really fast. Get it?
Oh.
Well, okay. Now, would you explain why sound travels in the air slowly, but in solid really fast?
I think I don't understand.
Don't say. You understood. Because let me say again. Sound travels slowly through gases because the particles of gas are furthest apart. So it takes time to travel. But in solid, no, because they're really close to each other and sound can travel faster. Get it? Let me show you something. Hannah, you want to travel from this place to this place and from this place to this place and from this place to this place. Okay, so tell me, which one can you travel faster? This
Solid.
one or this? Of course, solid, because they are really close to each other. So you can travel faster. And this one is liquid and this one is gas. It takes time. You know, you need to go to get this one. Get it?
Okay.
Now, can you explain it to me?
I think so.
You can. You can just try to say it.
Okay. A particle in gas is very far, and solid is close. So solid is faster than gas. Gas is slower than solid because gas have a space, very big space, and solid have close. Have small space.
Very good. Good job. You could make it, of course. Of course. So you deserve this. Yeah. Okay. Well, now let's keep going with the book. Okay. So, look. Well. Okay. And This one. So sound travel through different materials. Sound travel through solid and liquids and gases. Sound travels best through solids. Okay, what is this? What did you? Oh, what is this? What did you write?
Um, I write, and my hand put in something, so it's like this.
Well, okay, so it's okay. And now, sound travel through different materials, but how does sound travel? So let's read. Of course, we need to do an exam together. So would you read this one? Jumping rice.
Put the plastic wrap over the top of the jar. Keep the wrap in place with an elastic band. Sprinkle a few rice grains over the wrap. Hit the side of the jar with the pencil. What happened to the rice? Hold the tin tray close to the jar and bang it with a spoon. What happened to the rice?
Oh, so of course, we need to do this one, but we can guess, Hannah. We can guess. Look, put a plastic wrap over the top of the jar and keep the wrap in place with an elastic, something like plastic. Bend and sprinkle a few rice grain over the wrap.
What do you mean?
Okay, so let me say something. So can you see? Let me show you. Look, this is a jar, okay? Now we put a plastic, this one is plastic wrap, okay, here, and we close the jar using this plastic, okay? And we try to keep this plastic in its place using this band. This one, this is a plastic band, so we can keep the plastic, the cover plastic, in its place using this band. Now, we put a few rice, can you see rice grains? Okay, on the top of the wrap, okay? Now, we hit the jar. Ding, ding, ding. What happens? Yeah, what happens? Then these rice grains go up and down. Down, they move. Yeah. Why? 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 Do you know why?
Because I don't know. Because I don't know.
Okay, because you don't know, but you need to guess.
I guess the rice is fall down. Oh, this is a jar and the rice is here. We do like this, and then the rice go up and down, and then it fall.
Of course, because when we hit the jar, we are making sounds. So
it don't have a balance.
What do you say, dear?
The rice cannot balance.
Of course. Yeah. Of course. It shakes because when we actually hit the jar, we are making sound, and these sounds make the rice grains move. Okay, something like shaking. Get it?
Okay.
Sounds are made when things vibrate. And a vibration is a very quick movement back and forth. So for example, when you play the guitar, you are making the vibration so you can see and you can feel this actually movement. Okay, so tell me, have you ever played the guitar?
I never. I just
Never?
play piano.
So let me show you something. Let me show you something. I'm going to show you something. Just. Okay. Let me show you something so that you can get it. Okay. Well. Okay, I'm gonna play something. Okay, I think this one. So let me share my screen again. Wow. Look, look, look. Can you see? This is vibration. Can you see? They're shaking and they make sound. Can you see? Look,
Yay.
look, 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 look. Oh, can you see?
Yes.
Yeah. So the strings are moving or shaking and we call it vibration. Get it?
Okay.
Okay, so how can we make sounds? How can we make sounds?
I think we do something, a thing with a thing. And
Okay,
click.
so look. Would you read this one? Would you read this word?
Sound are made when things vibrate. A vibration is a very quick movement back and forth. You often cannot
Yeah.
see vibrations, but you can feel.
Okay.
Hold your hand in the middle of your throat and hum a tune. You will feel the vibration and hear the sound.
Okay, well, I'm going to show you something. Just wait me for 1 minute. I'm going to show you something. Well, okay, well, look, I'm going to show you something.
You get a
Okay,
guitar.
yeah, okay, there are strings. Can you see? Okay, and when I play the guitar, I'm moving the string. So as you can see, okay, when I vibrate, these strings, they make sound. Get it? So sounds are made when things vibrate like this. Okay? Get it? Okay, so how can we make sounds? You tell me, how can we make sounds?
Hmm. Hold your hand in the middle. No.
Tell me. Look, how can we make sounds?
Uh, Sound are made when things vibrate.
Very good. When we vibrate, this is vibration. Can you see? This is vibration.
You can
Okay, so we're gonna do something. Just, okay, give me a moment to, yeah, of course. Okay, well, now let's do something, okay? And now let's hold your hand, okay, in the middle of your throat and say okay, can you feel it? Say can you feel the vibration? Say no, close your mouth, okay, and put your hand here and say Can you feel it? Can you feel it? You know, here, your throat is vibrating. Hmm. Not ah. Yeah, can you hear? Can you feel it? Yeah, so this is vibration. Get it?
Okay.
Okay, well, now let's keep going. Okay. Well, tell me, Hannah, think back to the tin can telephone. You remember? Which materials vibrated when you used the telephone? Look, this one. Which material vibrated? This one. Which one? The string or the cans? Which one?
I think the string.
Excellent. You know you're really smart. Of course. Very good. So we learned lots of things. Okay, now keep going, keep going. Okay. Well, now look at the picture, Hannah. Okay, do you think the sound is loud or soft?
Can you wake me?
Of course.
I'm back.
Wow. Okay, dear. Well, let's do something. Okay, look at me. I'm talking to you. I say, Hannah. Am I talking? Am I talking loudly or softly?
Loudly.
Yeah, of course. Now I say, Hannah, Hannah. I'm whispering. I say something in your ear. Say, Hannah. Okay, so is it a soft sound or a loud sound? Soft, of course. So, tell me, when a motorbike starting up, it makes a loud sound or a soft sound?
A loud sound.
Okay, well, and tell me when we whisper. It's soft. Of course, of course. So, tell me when we listen to music, it's better to listen loudly or no?
Loudly.
Why?
I think if someone sing, oh, for example, you sing and I like your song. If you sing, if you sing is not a loud sound, it's a soft sound. I cannot hear, and
Oh, so you
and
cannot,
I
of course,
just
you may not. Yeah, of course, you're right. Maybe, of course, not all the time. For example, when we are alone in our rooms, bathrooms, we can listen to the music softly because we can hear. But when we have a birthday party, it's
we have
better.
to
Yeah.
listen to a loud sound because
Wow, of course.
people are talking, so we cannot hear the
Yeah,
sound
of
soft.
course. Of course, of course. Well, okay, now let's check. So we can do this, of course, at home. Maybe this is something that we can do at home. We can try it to make sound. We can try to make sound and then, yeah. Okay, so, okay, tell me, when, Hannah, okay, is the sound of the clock louder or softer when you move the clock further from your ear?
It's very soft
Why? Do you know why?
because if we far away for a thing or something, we cannot hear it clear. We will hear it.
Do you know why? Do you remember why? Do you remember why? Because sound needs to travel
Through our ear.
of course, travel, needs to travel in the air. And of course, it will happen really slowly. So, when, you say you know this. When we move the clock further from our ears, we can't hear the sounds clearly because sound needs to travel to get our ears, yeah?
Okay.
Yeah, of course. Let me say something. When we make a sound, actually we vibrate these particles. I vibrate this one, and this one vibrates this one vibrates this one, and and we make a vibration. They're shaking. Okay, so in gas it's difficult because, and it takes time because they are furthest apart. They're not close to each other, but in solid it's really easy. When I vibrate this one, the second one, what happened? Are you thinking? Okay, tell me, is it difficult?
A little bit difficult.
Oh, no, of course not. You know this one because you're really smart. I know that you understood all them.
No.
So, for example, something like, look, they are particles, Hannah. They're particles, okay?
What?
And I say, they are particles of solid. Look, like this, okay? They're really close to each other. And say, ding, and say, ding. So I can vibrate very fast, but in gas, they're apart and say, bing. Now I need to wait. Ding, 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 ding. So it takes time. Get it? Okay. Well, excellent, smart girl. Okay, my dear. So, okay, that's over. That's enough for this session. Of course, we will talk about it later again. Okay, my dear, do you have any questions, any issues related to the sport?
No.
No? Okay, very good. My dear girl, just this, and let me stop sharing because we don't need it anymore. Okay, my dear Hannah, time is over. We need to go. So have a great, great time and see you next session, my dear.
Okay, teacher.
Okay, goodbye.
Bye-bye, teacher.
Goodbye, my dear. Goodbye.